ChatGPT wasn't built overnight. It learned from enormous amounts of data, absorbing patterns from billions of conversations, articles, and books. But here's the thing. Companies don't retrain giant AI models every time they need something new. So what's the difference between training and fine-tuning? Today we're answering the next big question in AI. How do models actually learn? We'll cover what training is, what fine-tuning does, the data and compute needed for each, cost differences, and real-world applications that are reshaping entire industries. Modern AI models follow a clear life cycle. Raw data flows into a training pipeline, where it's processed at massive scale. Training creates a base model with general knowledge. That foundation is then fine-tuned with specialized data to create domain-specific intelligence. Each stage builds on the last. Most people confuse training with fine-tuning. They think they're the same thing. They're not. They have different goals, different costs, different workflows, and completely different outcomes. Understanding this distinction is critical for anyone working with AI. Training is how we teach a model general knowledge. Massive datasets flow in: books, articles, web pages, code, conversations. The model learns patterns, relationships, language structure, and world knowledge. It builds the foundation for everything that comes after. Imagine trillions of words flowing through neural networks. Wikipedia, GitHub repositories, books, scientific papers, news articles. The model processes this ocean of information, adjusting billions of parameters until it understands language, context, and reasoning. Training requires enormous compute power. Thousands of GPUs working in parallel across multiple data centers. Training runs that last for months, consuming megawatts of power. The cost? Millions of dollars. This is why training happens once, at massive scale. Fine-tuning is different. You start with an existing trained model that already understands the world. Then you continue training it on a smaller, specialized dataset. The model learns domain-specific knowledge without losing its foundational understanding. Take a base language model trained on general knowledge. Fine-tune it on medical journals, clinical notes, treatment protocols, and diagnostic literature. The result? A medical AI assistant that understands anatomy, pharmacology, and patient care like a trained physician. Same base model, different specialization. Fine-tune it on case law, contracts, legal briefs, and regulatory documents. Now you have a legal assistant that understands jurisdiction, precedent, contract language, and compliance requirements. One foundation, endless possibilities. Training builds the foundation. It uses massive datasets, requires enormous compute, and creates the base model from scratch. Fine-tuning improves the foundation. It uses smaller, specialized datasets, requires less compute, and adapts the model for specific tasks. Two different stages, two different purposes. Training needs an ocean of data. Terabytes. Trillions of tokens. Diverse sources covering the breadth of human knowledge. Fine-tuning needs a stream. Thousands or millions of examples, focused on a specific domain or task. Training requires a GPU city. Thousands of processors running in parallel. Months of continuous runtime. Millions in infrastructure costs. Fine-tuning requires a GPU cluster. Dozens of processors. Hours or days of runtime. Thousands in costs. The difference is enormous. Training from scratch costs millions and takes months. Fine-tuning costs thousands and takes days. For most companies, the choice is obvious. Fine-tuning delivers faster deployment, lower costs, better ROI, and specialized performance without rebuilding the wheel. Healthcare organizations fine-tune for patient care and diagnosis. Financial firms fine-tune for risk analysis and fraud detection. Law firms fine-tune for contract review and compliance. Customer support teams fine-tune for their products. Every industry is adapting AI. Fine-tuning is not building a new model. It's not training from scratch. It's not replacing the foundation. Fine-tuning adapts an existing model. The foundation stays intact. The specialization changes. Here's the full picture. Data collection feeds training. Training creates the base model. The base model gets fine-tuned with specialized data. Fine-tuning produces domain-specific AI. That specialized model serves real-world applications. One continuous pipeline from raw data to intelligent systems. Training creates the foundation with massive data and compute. Fine-tuning specializes it faster and cheaper. Training happens once at enormous scale. Fine-tuning happens continuously for specific needs. Most businesses fine-tune instead of training from scratch. The economics and timeline make it the practical choice. Training builds the brain. Fine-tuning teaches a profession. Together, they create the foundation. But what happens when you actually use an AI model? When you type a question and get an answer? Next up, we'll explore inference and discover what happens behind the scenes.